Hello, welcome. This is the GH Additional Maths and Science Clinic for BEC candidates. We are available online at the various social media handles at GH Additional TV. This lesson takes place Sundays from 3 to 6 p.m. Taking this opportunity to also let you know that we have mock examinations that runs for BEC candidates, which is online, and also for schools, which is in print form. So you can get in touch with us for these details. Now in today's lesson, we'll look at the content of what we'll be doing, introduction to the course content. Then we'll talk about matter. We'll introduce the course, and then we'll talk about matter. Now the topics to be discussed from your books and from your text materials. The science course has over 35 topics. However, we've managed to group these under 7 broad thematic areas. So we'll be talking about matter, the state of matter. We'll talk about agriculture and plant life, the implements used in the farm, the various agricultural cultural practices. We'll talk about the plants, how they are propagated, etc. Then on topic 3, we'll talk about energy, how energy is obtained, how energy is transformed from one form to another, how to do basic calculations on energy. Then we'll come to our environment, everything concerning our environment, environmental degradation, how to maintain the environment, gas exchange in our environment, pollution, etc. Then on topic 5, we'll pick the human being. We'll talk about systems in man, how cells form tissues, etc. We'll also talk about the various organs and organ systems, your circulatory system, talk about the blood, etc. We'll talk about the respiratory system, how you take in oxygen, how you're able to break down food, respiration, how you're able to obtain energy from it. We'll talk about digestion, etc., etc. Then we'll talk about diseases. We'll pick diseases of humans, talk about how they are acquired, how they can be prevented. Talk about those of plants, disease of plants, how they affect plants, plant production, etc. Then when we are done, we'll look at some other topics that are relevant for you to excel in the BEC. So there's a gist of what we'll be doing for the next few months till we write the examination. So we start with matter. Now the lesson objectives. We'll be looking at what matter is. We'll try and understand what the atom is, the molecule, and ions. Then we'll come to states of matter: solid state, liquid state, gaseous state. Then finally we'll look at the changes that takes place from one state to the other. What is matter? Now I know you know your definitions, so I would add on. So matter is anything that has weight and volume, or matter is anything that has weight and occupies space, meaning that anything you see on this earth is matter. The book, the pen, the pencil, eraser, the car, even the air is matter, because air has weight. If you think air doesn't have weight, pick up your gas cylinder and go and fill it with gas, LPG gas. You realize that the weight has changed, and that is air, or a form of gas. So anything that has weight and occupies space is matter. Now, matter consists of tiny particles, and these include atoms, ions, elements, molecules, compounds, mixtures. So you can have an atom, which you know, the smallest unit of life, ions, elements, molecules, compounds, mixtures. Now let's talk about the atom. So by definition, the atom is the smallest particle of an element that can take part in a chemical reaction. Now mind you, can take part in a chemical reaction is very important, because without it taking part in a chemical reaction, you can't call it an atom. So as always in your definition, you say it's the smallest particle of an element. When you end there, you earn half a mark. When you add on, that can take part in a chemical reaction, then you are there. So examples include all the atoms you know, sodium, carbon, potassium, chlorine, etc., etc. Name them. So an atom is not just the smallest particle of an element, but that can take part in a chemical reaction. Now, in addition, you know that an atom has a nucleus and it has shells. And the nucleus possesses your protons and then your neutrons. Then on your shells, you have electrons. Now these also have charges. Your electron is negatively charged. Your proton is positively charged. And then your neutrons, like the name sounds, is neutral. It has a neutral charge. It has a neutral charge. Now we talk about the molecule. If you ask what is a molecule, it is the combination of two or more atoms that is stable and can exist by itself. That is stable and can exist by itself. Now, being stable and being able to exist by itself is very key for you to call it a molecule. Now, scientifically, you can cause some atom to come together, but it will not be stable because it cannot become a molecule. We can't call that a molecule. But then, when two or more atoms come together and then they form a stable product which can exist by itself, then it is called a molecule. So always make sure you add the fact that it is stable and can exist by itself. Sometimes we take some of these definitions for granted, but they are keywords which you need to always note as being part of your definition. And examples of these include oxygen. O2 means that two oxygens have come together. We said two or more. We have H2O means two hydrogens and an oxygen has come together. Now, by the number of atoms coming together, we can talk about a monoatomic compound, a diatomic compound, a triatomic compound, even a tetraatomic. Now, a monoatomic molecule has one atom. So, example, helium, as helium gas, is made up of one kind of atom, the helium. Now, the helium alone doesn't need to bind to another helium to give you the helium gas. They are independent, but because they are in one compartment, it will give you a molecule. Same for argon. Now, when we talk of diatomic molecules, it means that two atoms have to join to form a stable product. That stable product can now be called a molecule. So, for instance, if you take Cl for chlorine, Cl for chlorine cannot be a molecule, but Cl2 is a molecule. So, when two have come together, we'll call it a diatomic molecule. In the same way, sodium chloride, that's common salt, is made up of sodium and chlorine coming together. Independently, they are atoms, but when they come together, they form a molecule. So two atoms coming together, diatomic molecule. Then triatomic molecule, 3 atoms coming together. So like I mentioned earlier, water is made up of 2 hydrogens and an oxygen. That makes it 3 atoms, triatomic. Now O3, and you should know O3. O3 is ozone, like the ozone layer. Now ozone O3 is made up of 3 oxygens. Now these 3 oxygens form a triatomic molecule, 3 different atoms, triatomic. Carbon dioxide, CO2, is also triatomic, 1 carbon and 2 oxygens. This gives you 3 atoms, so triatomic. So you should be able to name or list diatomic molecules, you should be able to list triatomic molecules and monoatomic molecules. Now let's talk about the ion. Ion, I-O-N, ion. Now, it is an atom with a charge or a group of atoms that have gained a charge. An atom with a charge or a group of atoms that have gained a charge. So it can be a single atom with a charge or 2 or more atoms which have a charge for that group. Now, how do you come about this charge? The charge is as a result of losing or gaining an electron. Losing or gaining an electron. So when you gain an electron or you lose an electron, you would have a charge. So a charge is as a result of gaining or losing an electron. Then we talk about a cation. Now, a cation has a positive charge. So it is an ion with a positive charge. Now, if you have a positive charge, how do you get that charge? Remember that atoms have negative and positive charges. The electrons in an atom have negative charges. Then the protons have positive charges. Now, depending on whether you are increasing your electrons or losing your electrons, you become more negative or more positive. Now, the number of electrons and protons are equal. Once you reduce the number of electrons down, the protons will be more. So assume they all have 5, 5, and you reduce the electrons by 2. The protons will now be 2 more than the electrons, so it will be positively charged, 2 plus. That will make you a cation, or give you a cation. Now, for an anion, you are gaining electrons. So assume they all have 5, 5 charges, or let's say 7, 7 charges. And then you decide to add to the electrons 2 electrons. That will make the electrons 2 more than the protons. Meanwhile, you know that the electrons are negatively charged. So if you add 2 more electrons, you have added 2 more negative charges, making the anion negative 2 or 2 negative. So that's how come cations and anions are formed. So in brief, cations are positively charged because they lose electrons, and anions are negatively charged because they gain electrons or an electron, whichever way. That will give you a cation and an anion. Then we talk about an element. Now, an element is a substance that is made up of the same kind of atoms and cannot be broken down into smaller units by any chemical means. So the same kind of atoms, and you cannot break them down by any chemical means. So we have chlorine. Chlorine is bound together in nature as it is, Cl2. Oxygen, it is O2, bound together as oxygen. Ion is Fe, just one Fe. It's so in nature. So it's a substance that is made up of the same kind of atoms, and you can't break it up. Then when we talk about a compound, it is a pure substance formed by the chemical combination of 2 or more elements. So the element above when two or more come together, then it forms a compound. So it's a pure substance formed by the chemical combination of two or more elements and has different properties as compared to the elements it is made up of. So for example, if you combine iron and that's Fe and chlorine gas, Cl2, what it forms is different from what Fe alone is and what chlorine alone is. It forms something totally different. Take hydrogen gas and oxygen gas. Now hydrogen gas and oxygen gas comes together to form water, H2O. The properties of hydrogen gas, the properties of oxygen is different from water. And that's what we mean by a compound. So it's a pure substance formed by the chemical combination of two or more elements, but then it has different properties compared to the elements they are all made up of. Then a mixture. It is two or more substances that are brought together physically and cannot be separated by a physical means. And can be separated by a physical means. So you bring them together physically and you are able to pull them apart physically. So you take salt solution, you add sodium chloride to water. It's physical combination. You can separate them by another physical means by evaporation. So they are not mixed chemically. When you take air, you have oxygen gas in there, you have carbon dioxide in there. You can separate these into their constituent gases, but together we call them air, but they are not chemically combined. They are physically combined, so you can separate them by a physical means. So that's a mixture. So for your assignment, go and review the atomic structure. Then you review the elements and then symbols and the atomic structure. So if you take, say, chlorine, you should be able to draw the shells and the configuration thereof. So review that. Okay, now let's talk about states of matter. States of matter. Now, matter can exist as either a solid, liquid, or a gas. Solid, liquid, or a gas. We agree that matter is anything that has weight and occupies space or volume. So a solid is matter, liquid is matter, gas is matter. Now these have characteristics. What are the characteristics of these? One key feature of solids is that they have fixed shape. So if you take a stone, it has a fixed shape. If you take a cup, it has a fixed shape. And this is because the bonds in there are tightly packed and have a strong force of attraction between them. Now, between one atom and the other, there is a bond. Now, the strength of the bond will determine whether the product or what you have is solid, liquid, or gas. So you are saying that for solids, they have fixed shape because there are bonds in there that make them tightly packed, and these have strong attraction between them. The bonds are strongly attached to each other. Then we come to volume. They have fixed or definite volume. So if you take a stone, if you take a book, if you take a pen, the volume will never change. It is the same. And we are always saying that you cannot compress them. You cannot compress them. Now by compression, let's take say a spring. When you take a spring, when you press on it, it gets tightly packed together. Now we are talking in terms of the atoms that make up a solid. The atoms that make up a solid will not allow you to compress them. It doesn't allow you to compress them. So that is also one of the characteristics. And we are saying that they cannot flow because the particles are tightly packed. So all those things are linked to how the atoms are arranged. The atoms are close to each other. So it cannot flow like water. No. Solids cannot flow. So we are saying that they have fixed shape, they have fixed volume, they cannot compress them, and they do not flow. These are the features of solids. Now liquids. Liquids. So our first point here is it doesn't have a fixed shape. So water doesn't have a fixed shape. It takes the shape of the container. So if you put water in a cup, it will take the shape. If you put it in a bottle, it will take the shape. So it has no fixed shape. And this is simply because the atoms are less packed than what you find in solids. And also the force of attraction between them, that is the bond, is not as strong as what you find in the solids. So they have no fixed shape based on the explanation I just gave. However, they have a definite volume. They have a definite volume like solids. So if I pour a cup of water into a bowl and I bring it back into the cup of water, it will have the same volume. The volume doesn't change. And then in terms of compression, they are saying that you cannot compress it. Now you might think that it's compressible. Get a container or a plastic bag filled with water, and then without any outlet, try and press it. You can't compress it, you can't make it smaller. It will stay as such. It may move, but that is not compression. Compression is about reducing its volume. So it cannot be compressed. Then the final will say it can flow because it can slip past each other. The atoms or the particles can slip past each other. Unlike in solids, which you said cannot flow, liquids, which an example of that is water, can flow. So the characteristics or the properties of liquids, they don't have a fixed shape, but they have a definite volume. They cannot be compressed, but they can flow because the particles slip past each other. Then we come to characteristics of gases. Characteristics of gases. Now, the first point is the gas doesn't have a fixed shape because the bonds are loosely packed than solids. So you take a can of mosquito spray, you spray it at one of the corners of a room. When someone is standing at the next side or the next end, he can smell it or she can smell it. That means that the thing doesn't have a fixed shape. If it were water, it will not come to the person. But then this one has no fixed shape, so it moves anywhere, everywhere. Then we are saying that it has no definite volume. So the volume will depend on the size of the container in which it finds itself. The volume will change. So if you put LPG gas in a small LPG cylinder, that will be the volume. When you put that one too in a room, it will occupy the whole room, and that will be the volume. So it has no definite volume alongside no fixed shape or no definite shape. Now when it comes to compression, it can be compressed. That is why the LPG gas is tightly packed in there. Sometimes it even turns into liquid because of the compression in there. And then we are saying that it can flow. And that's what I explained with the mosquito spray. You stand at one point, you spray, at the other side, someone can smell that. So that makes it a substance that can flow. So in summary, we are saying that gases' properties or characteristics are no fixed shape, no fixed volume or definite volume. It can be compressed and it can flow. Now, for your further reading, find out about the differences and similarities between solids, liquids, and gases. The similarities between solids, liquids, and gases. So look out for the differences and similarities between these three states of matter. Now we talk about change of state of matter. We agreed earlier that matter can be solid, matter can be liquid, and matter can be gas. Now, you can have one substance exhibiting all these three characteristics. All these three characteristics. So take water for example. Water can be a solid, like ice cubes. When you put it in the deep freezer, it chills and turns into a solid material. Water can exist as liquid, like the water you drink in daily. It's in the liquid form. Then water can be in the gaseous form, like water vapor. Now all these are the same water, H2O, but then it exists in different states. That's why we are talking about change of state of matter. Change of state of matter. So we'll look at how one state converts to another. So we'll do one, then we'll do the reverse. For example, we'll do solid to gas and then the gas to the solid. We'll do solid to liquid and then liquid to the solid. Then we'll do liquid to gas and then gas to the liquid. So in a triangular form like that. So let's start. So now when you convert from solid to gas, it is called sublimation. Sublimation. Now you take camphor or naphthalene ball, that white ball that we use to ward off ants and all that in our rooms. Camphor, popularly called camphor. It's a solid. Naphthalene ball is the name. It's a solid. Now when you put it there, it doesn't change to liquid before gas. Regularly, the state of matter should move from solid to liquid to gas. But for this naphthalene ball, it moves straight from solid to the gaseous state. So that process is called sublimation. Now you can also have the gas moving into solid. The gas moving into solid. The gas moving into solid. When the gas is moving into solid, then we call it deposition or deposit. It deposits. Deposition. Deposits. So for instance, if you have dust in a room, after a while, it will settle on surfaces. That will have become a solid at that point. If it goes on for a while, it will actually become a thick thing that you can touch. Take the roadside, you have air carrying dust through. After a while, you see that at the roadside, there's some deposit of sand there, and that is deposition. So from gas to solid, that's the reverse of solid to gas, is deposition. Then we take solid to liquid, from solid to liquid. Now that is a regular process. The regular process is for solid to turn to liquid. So if I give you ice block, now ice block has a low temperature. Now when the temperature becomes room temperature, it will turn from solid to liquid. It will turn from solid to liquid. Now shea butter, no shea butter. Now shea butter is a solid. It can turn to liquid. However, for shea butter to turn to liquid, you would need to apply heat for it to turn to liquid, because the temperature required to melt shea butter is not room temperature like ice block will melt to water at room temperature. No. Shea butter requires that you apply heat to convert the solid to a liquid. Then we have liquid to solid. That's the reverse, liquid to solid. And that is solidification. If it's the shea butter, we call it solidification, solid, solidify. If it is the ice coming from water to solid, we call it freezing, freezing. So you are either solidifying or freezing when you want to move from liquid to solid, solidification or freezing. Then you can do liquid to gas, liquid to gas. So if you take water to move from liquid to gas, you would need evaporation. If you take petrol can move from liquid to gas. It will require evaporation. In the case of water, you need to boil to get it to evaporate because the boiling point is very high, 100 degrees Celsius. But when you take petrol, you don't need even boiling. It can escape into gas just by opening it up to the atmosphere. So from liquid to gas, you need evaporation. Then the reverse, from gas to liquid, you have to condense. A simple idea of condensation is what happens when you are cooking. When you are cooking and you put a lid on the food, you realize that no matter the space between the surface of the food in the saucepan and the lid, water forms on the lid. Now, that water that has formed on the lid is condensation. Why is it condensation? Because the water in the container or in the saucepan is liquid. When you boil it, it will turn into a gas. Now that gas is what goes to the lid of the container and then condenses. From that gas vapor, it turns into liquid on the lid, and that is condensation. Now this same process is what is used in alcohol distillation. If you want to distill alcohol, you would need distillation, and that distillation depends on condensation to form the alcohol. But the alcohol will be mixed with water and other things. When you boil, it evaporates, then it goes to condense. Then your alcohol has been formed. So that's about the changes of state of matter. You can talk about sublimation, solid to gas, deposition, gas to solid, melting, solid to liquid, solidification or freezing, that is a liquid to solid, evaporation, liquid to gas, and then condensation from gas to liquid. So these are the various processes required to change matter from one form to the other. Okay, so we've come to the close of this session. We didn't intend to pile you so much. So your assignment will be on the platform. Information about the assignment being placed on the platform will be sent. And then you take time to answer your assignments. You get a marks for the previous assignment. From tomorrow, you have access to your marks and then you do the new one. Thank you very much, and I plead with you. BEC is drawing very close, and you need to commit so much time to studies. Commit so much time to studies. Closer are we getting to October? June is ending, and you need time to prepare. So please push yourself hard. Take out some of the distractions, the computer games, the games on your phones, the music you've been listening to endlessly, the time you've been spending with your friends outside. Cancel out all those activities and invest this time into your studies. And I know it will pay off. Alongside Sundays, we'll meet and have our maths and science clinic. Thank you for your time.